Today we're going to be talking about residuals. Yesterday we learned how to find scatter plots, and today we're going to be talking about whether or not the best line of fit is the best line of fit. So we need to talk about a couple things. First of all, we need to talk about residuals. We have a positive residual and a negative residual. Positive residual indicates that the observed value above the line is above the line of best fit. A negative residual indicates the observed value is below the line of best fit. But what if my residual that I find is equal to 0? Well, that means that the value would be on the line of best fit. In other words, it would be predicted values that would be the same. So let's look at the graph. So if we see here, we have positive residuals that would be above the line, a negative residual would be below the line, and the actual residual, if it's 0, is going to be right on that line of best fit. Okay, so what is a residual? A residual is the difference of a y value of that data point and the real value that we would find using the line of best fit. So that positive, negative, and 0 that I was just talking about is called the residual error, the exact distance between a data point and the graph of the line of best fit. Remember, in order to find the line of best fit, we have to take 2 points, find the slope, and then find B. And then we can have the line of best fit. A residual can be positive, it can be negative, or it can be 0. We can use these values to predict what the outcome is going to be in the line of best fit. Now, as we look at residuals, we need to look for an even distribution. When the residual plots are random, then that is an indication that the line or the model is a good fit. But if it's non-random, then it is not a good fit. So let's look a little closer at these examples. So the one on the left, we see here we have points that are evenly distributed between or above, so positive residuals and negative residuals. But this one looks like there's an actual pattern. So when I see an actual pattern, even though there's a pattern, sometimes that can be confusing. It is not a good fit. The table shows the ages X and salaries Y in thousands of dollars of 8 employees of a company. And look, they've given me an actual line of best fit equation. Is it a good fit? Well, what do? Well, the first thing I need to do is I have this in a table and I would like to go ahead and find the residuals. So I'm going to plug in X to find the actual what Y would be. And then after I find what Y would be, I'm going to subtract that residual from the original. So for the first one, I found out by plugging in 35 that I got 45, and then I subtract. Please pause the video, and then when you have all of those figured out, restart the video. So, welcome back. And so now let's look at what I have here. I have all my residuals calculated. And remember, I did that by plugging in my X value to find the real value of Y using my equation of best fit. And then I subtracted what the value of Y was from what the model of Y should be. Now I need to graph those. How do I graph them? Well, I have to graph the X value and the actual residual. Please stop the video and restart it when you have your graph done. So, what have we done so far? Well, we were given some data. We were given the actual equation of best fit. We had to plug in the X values to find what the y value for the model would be. Then we subtracted the residual from the original to find the residual points. Then we graph those residuals. Now what do we need to do? Well, we need to analyze the graph, that residual graph. Does it make a pattern or does it not make a pattern? Is it evenly dispersed? Well, I'm looking and you know what? There's more above and it kind of looks like it's a parabola. So I'm saying no, it is not a line of best fit. Okay, you're going to be on your own this time. This time, again, I'm giving you some information, some data values. I'm giving you the line of best fit. I want you to find the y value using the equation and then find the residuals. Please stop the video and restart it again when you're ready to see the answers. Okay, now here's the actual residual graph. You might have graphed your own, but I went ahead and graphed it too. Was the line or the equation a line of good fit? Why or why not? So let's look at this. Well, I can see there's a lot of positive residuals and a lot of negative. They kind of look evenly dispersed around the x-axis. So I'm thinking, because they are evenly dispersed, that it is a line of good fit. Well, that's all I have for today. This is about residuals. You can go back and watch the video if there were any questions that you may or may not have had. Thanks. See you again soon.